This is Henk Akkermans and this is Smart Asset Management Lecture 10, Section 4, Mobile Sensor Applications. I could have given this section many names, but let's try this one. Another one will be interorganizational sensoring, or, well, if you scratch your back, I'll scratch mine. What's the point? Well, the point is that there are many different types of technical assets, as we saw already in lecture 1. And an example where you have very different types of assets leading to very different maintenance needs is, for instance, between the network technical assets and the mobile technical assets. And the interesting thing there is that they need each other, isn't it? So the ships, they go through canals, the trains go over the tracks, the cars and the trucks go over the roads. So the roads and the cars, etc., those are networks. And because those networks are so vast, thousands of kilometers or more, typically mobile maintenance teams have to travel around to inspect them and see what's happening. And at the same time, every day that network, all of it or most of it, is being visited by those mobile technical assets, but not with the purpose of doing maintenance or inspection or anything else, but just because that's what they do. They are mobile and they use the network to be mobile. So how about it if we would use those mobile technical assets to do some of the maintenance work of those network technical assets? What if skippers in a canal could signal and report debris in the water which may harm sluice doors or damage? What if planes, when they move over the tarmac to taxi to their departure place or on the way back, if they could notice bumps and report those? What if cars also could notice bumps and degradations in the road and report those? What if cyclists could even signal and report degradation? Perhaps their bicycles will get smarter, smarter all the time, but probably also the cyclist itself with their smartphones. And last but not least, what if trains? What if trains could signal and report degradation of railroad tracks and switches? Now, that's actually not a hypothetical question, that's actually been done already. So this is a presentation by Paul van der Voort of ProRail. ProRail is the Dutch national asset owner for the rail infrastructure. That's their logo. The company that runs the trains and deals with the passengers, that's NS. And yeah, they used to be one national company, of course, but in the 1990s they were split up and still are split up. So these are two different organizations and with two different assets owned by different people with different IT systems to monitor, etc. And yet they could help each other. The CAMINO Rail project is a serious attempt, and so far a successful attempt, to see if they could help each other a bit more. CAMINO is yet another of those world-class maintenance field labs, open innovation programs. This time it's in the infrastructure. It stands for condition-based maintenance in the infrastructure network organizations or something like that. Anyway, there are multiple parties there. There is investigation of sluices, and we've seen those of sewage, of bridges, but also of rail infrastructure, and that's called CAMINO Rail. And CAMINO Rail starts from the realization that that's on 10%, actually 1/8 or 1/7, whatever you want, of the defects that are caused for trains. 12% of those is caused by some material defect from the transporting company, from the trains, from NS. 14% by some defect in the infrastructure, and then that's ProRail. There is an overhead broken line, and as a result of that, we can't continue. That's frequently heard by train travelers in the Netherlands, at least. Now, there are two clear places where train and track infrastructure interconnect. There's the wheel-rail interconnection, and there's the overhead line electricity connection there, the pantograph connection. So at these places quite often degradation occurs, but also these are places when they can measure each other. So let's do so. And that's what was being done there. And Leo van Dongen, who was by then the Chief Technology Officer of NS, played an important part of it, because this was one company, NS, doing something which cost them time and money to help another company, ProRail, because the trains measure degradation not on the trains, but degradation in the rail. And of course, if there's degradation in the rail, that will lead to bumps, etc. And that may over time increase degradation of the train, but still. So what they did is they mounted sensors on 2 passenger trains, but those trains travel a lot. And since then it's been scaled up to more trains, but still. So here's a very successful case study of just 2 or 3 months. They had these 2 trains running on these tracks, and every time they had a bump, they would measure with the sensor the vertical acceleration, and of course would know when that was. And because of that, you could very precisely locate in the geographical information systems of ProRail where that NS train was when that bump occurred. Now they spotted just at least 10 major defects in a month, or major significant defects, a significant bump in the road, and they had this wonderful thing of the trigger of the week. And the biggest trigger then was looked at and was also communicated with the service provider actually doing the daily maintenance of the railroad track. And in some 90% of the cases, over 90% of the cases, that was correct. There was something wrong there, and it needed to be fixed, and it needed to be quick. And that's wonderful, isn't it? So although normally there are measurement trains going over this entire, all the 3,000 kilometers plus of railroad track in the Netherlands, still apparently they missed some. And this stuff then was pretty good in measuring it. Why that is, I don't know. Perhaps because passenger chains are heavier, because the sensors were better, because I don't know why. But the point is that this was a very successful case, since with a very small investment in time and money, they were able to find a very high successful percentage of immediate repair work. Now they've looked at other opportunities, doing stuff with audio, with microphones, so that you could get more insight into the sound that actually the train was making, and also accelerometers that could actually indicate, vertical accelerometers, the relative height of the train. So see if there are some vertical gradual degradations or in the train, in the track. And then probably because the underlying earth was moving, which happens quite a bit with climate change in the Netherlands, more than it used to. What did help in the project side was the fact that it just so happened that both organizations used the same cloud solution, this case Microsoft Azure, because of course you need to get these data from the sensors from NS to the location data and the asset data from ProRail, and make a connection between those. The stuff needed to be programmed. They did it in Python. They had some Scrum stuff there. There are the people that actually did that. I took their mugshots away for privacy reasons, but those were data scientists. And what also helped is the companies had, certainly NS, had those people already around, but then much more for data science of passenger movement, more commercial marketing applications. And for them, this was the same methods applied to a different area, the area of asset management. So there are more pilots being discussed and evaluated, especially on the pantograph. So that's the thing that takes the power from the overhead line and make sure that the train can run But actually the more significant development is that that's now being, and that's not easy because there's a lot more politics and budgets involved there, is now gradually being scaled up to do this on a daily basis, because there are still 3 measurement trains costing a few million euros doing this stuff. So why not this solution? Keep you posted on that, but as a sensoring application where one organization senses something that helps the other organization, I think this is a very nice example.